Well, I think today we probably can go through some of the open questions that we didn't get discussed last time. I think Benny lists a couple, I also list a few. I think that's also probably more from the PR comments. After we go through this open question, we can go through some of the open question on the PR comments. Benny, I think the first one, is that already discussed?
Yeah, the question is really, looks like we're deciding to at least have that list of different types of objects inside. So the question is, how do you represent the nested view inside those lists of objects? Like, is it, I was suggesting that, like, instead of having, like, to separate out the nested views from just the logical views, so that the consumer knew that the producer used a nested view or nested materialized view to refresh, as opposed to just expand it out.
So I think we discussed it. We're saying we let the producer decide, right?
No, I think this is more the structural question, right? Of the two lists versus one list with kind of like a typed entry. Is that what you're talking about, Benny?
Yeah, I think we agreed I think we said it was going to be one list, right? But now we have these types, right? So you got view and table. Should we have like a materialized view type to indicate that producer used a materialized view?
On spec, there is a materialized view type, by the way.
Yeah, I added it.
Yeah, I also think that's also related to the how we expose that material view. I also think like the material view type, but maybe we can wait a little bit after my question about how do we load that from catalog.
Load the materialized view?
Yeah.
Well, you load it by name, right? Just like everything else. Everything has to be loaded by name. And then the materialized view has a storage table that also has to be able to be loaded by name.
Okay, maybe we can jump to the question I have. I think Dan, remember in 2 minutes agreement, can the consumer load MV storage table direct from catalog, right? Because consumer need to be able to do that. Now, I have a question. Sorry.
So the storage table, the discussion, and like this goes back a little ways. The storage table has to be able to be loaded by name because we don't have a way to load a table any other way, right? Yeah. So it has to be able to be loaded by name. And the difference is like a catalog can choose whether that table shows up under a listing operation or not, but you have to provide a loadable reference for the name, or I mean for the storage table.
So that's actually my question. How do we expose material view, for example, with the REST catalog? Today, when we talk about view, it may take 2 round trips. You first, because engine, when I have a name, it doesn't know it's a table is a view. You first do a load table call and set, oh, it doesn't exist, then you try load view. So take 2 round trip. But with the material view, we may take a 3 round trip. So first load table, it's not a table by the name, by the material view name. Then load view is not a regular view. Oh, you loaded the view by the data. Then you need to load the storage table. So we do 3 round trip. So I was discussing with our multiple, can we have a load table view API? Potentially we can just have 1 round trip to get both the material view metadata and the storage table in one shot.
I think that there is a open discussion about like either a bulk API or a load, like a load multiple API kind of thing. I think we should separate that from this though, right? Because I don't want to necessarily have to go and create those APIs in order to get MVs to work. Like those are separate concerns. That's an optimization of how we resolve the actual storage table, right?
Because that's also titled also access control. Let's say if you define access policy on the view definition, now should that be applied to the storage table loading?
Well, so let's get to that. Let's solve the first problem first, which is how are we referencing these things? I don't think that it changes anything about what we would put in the list, right? So let's tackle that, and then we can probably have the discussion about the permissions and like what does that mean. And then the question about like updating the endpoints for bulk APIs, I think is a separate discussion. I think we're open to having that discussion, but like I don't want to tie these together because we don't actually need that in order to address the MV questions. John?
So I think, so the new API, you kind of want to have the engine to be the first call to kind of to the right API, because if we introduce like a new endpoint in the future, it should be the first endpoint that the query engine queries, right? Because we want to reduce the number of round trips. And I think like introducing this kind of universal endpoint after the fact that we have already some other endpoints is going to be difficult, because many people are already building systems that will always call maybe like a load table API first.
We already
even though
that's where we are today. Like everything has to call load table first right now. And so saying, hey, we need to define this new endpoint because maybe somebody will, build against load table. That's how everything is built today. So it's actually like, an engine doesn't know what it's resolving. So it doesn't know it's an MV before it goes through the current path of load table, load view. So we have to solve that problem if we want to move to a bulk API where an engine can just find all the identifiers that need to be resolved, send them in one shot, and get all the results back. I mean, there's definitely a reason to pursue that, but we're already in the situation that you have to call load table right now.
I was thinking that maybe we could introduce like a new error type that when you call load table and the catalog recognizes that it has a view with the same identifier, it returns you an error and says, okay, this is a view and the according storage table would be under this name, so that you only would have like 2 round trips. That you get an error back which tells you, okay, I requested a view and the according storage table is under this identifier. So you would at least save 1 round trip.
This is a complicated area, and I don't think that there's an easy solution to this because the APIs that exist today don't support the kind of things that we're talking about here. What we would really need to do in order to introduce that functionality is add new catalog interface APIs, new REST APIs, and then change how the path works for loading and resolving tables. Because, I don't see how we solve this problem without going all the way back and figuring out a full through and through bulk API load mechanism. If we try and point solve it for materialized views, we may save 1 hop for the storage table. And we add a lot of complexity, and it's a different thing than how we do other loads. So the other option that was floated was that, hey, you can return the actual table metadata with the view definition when you load a materialized view, so you don't get that second hop, right? So you get the actual view definition and the storage table information in the same payload as a result. We can explore all those options, but I don't think that's relevant to what we're talking about right now.
Yeah, I think that's okay. To Bennett's question on if we have a material view type in the single list, should that state combine both view method, let's say view version ID and storage table snapshot? Or should that have one entry?
That's a good question. I think for each of these, we should probably just write down, hey, what do we think the fields are that we need for each entry in that list? So I think we've largely said for tables, you need the name, the UID, and you need the snapshot, right?
Yeah.
And then
it's in the
for
PR, right?
Yeah, it's in the PR.
If you go to files,
sorry, can somebody drop that in the channel just so I can?
Yeah, there's 3 types: the source state.
It was the bottom, right?
yeah, it's at the bottom, yeah.
You had the 3 structure: view record, table record, materialized view record, lower. So very close to the lower source table
Yeah,
state.
lower.
Yeah.
So that's table, non-view, and then materialized view.
Oh, shadow zoom it in a little bit. Yeah, this is a table state.
That's table state. Yep.
The view state will be just a version ID.
View state.
Everything else is a common. One is a
Mhm.
snapshot ID. Table have a reference also.
And then materialized view below it.
Oh yeah, I think right now you don't have it, but combined already, yes.
Yes.
I think this makes sense to me. I think I'm good with this.
What should we include the storage table path?
Yeah, you need the storage because you have to load it by name. You need the storage table's name and catalog.
Yeah.
And that's why I almost feel like, you know, you could include that just as a table, right? It is a table for all intents and purposes for loading and resolving. The question is, do we need to know that a reference for a table that is a storage table is a storage table for some reason? Do we need to know?
Valuable. Yeah,
I think some engines would try to analyze what the schema of upstream materialized view has changed, right? If our column changes, we may treat it as stainless violation. Or you like whatever star using star and you get new columns. So I think that's important.
Yeah, you don't actually, I don't think that you want. Well, you actually know what the storage table is already, right? Because that's part of the view definition itself. Oh, this is for the nested. This is a nested view definition.
Yeah, that's okay. That's my upstream.
Okay, but when we load a materialized view, we would get the same information about the storage table, right? So what we don't have is what was captured as the state at this point that was resolved as part of this view. So what is the minimum set of things that we actually need? It's not even the storage table UID.
Well, we need a UID though.
I think the UID would be like an optional field, maybe on the view struct where you have storage table UID, and if it's set, it's a materialized view, and you could identify the according storage table from the list. And if it's not set, then it's a common view.
So I actually think now that I'm looking at it, what we have here is actually all that we need. Because you wouldn't necessarily want to include it in the storage table list. When I go to resolve the state for this materialized view, I'm going to load this materialized view. I need the storage table UID to make sure that the storage table hasn't changed state. I have the name of the storage table from the materialized view that I load, right? So I can use that to then load the storage table. It doesn't need to be in the record. And I need the snapshot that was captured at the time that this view was refreshed, which is the storage table snapshot ID.
So this is source material view started.
What?
No, this is source material view start table. We still need the source material view start table's name, right? To be able to load
you get it when you resolve the view, right? We're going to resolve the materialized view, and that has the actual name and the UID of the at least the name. I don't know if we're capturing the UID. I assume we have the UID as well of the actual underlying storage table. So we get that through the materialized view load.
We talk about the consumer is processing this list to do expression evaluation. Consumer does not need to pass the SQL to determine the source material view.
It's not parsing the SQL, it's just loading the reference. That's what we're doing with these values in this list, right? Any client.
But this is about the source, like where the data was coming. It's not about the storage table that is related to the materialized view. These are the fields that come from the source materialized views, which we don't know the storage table reference, like when we look at this. And I think in order to query the catalog to get the current snapshot ID of the source table, which belongs to some materialized view that we're referencing, we need the storage table identifier, and this is what's missing here. I think this is kind of.
I think what Dan Paul is saying is, we know this is source material view. We can load that source material from a catalog to find the storage table name.
In fact, we have to load it from the catalog because we have to validate the materialized view as well. So we, as we go through it, like any source tables that were part of that materialized view that the producer actually wants to be evaluated to, you would add to the table list, right? So that's kind of the nested source tables. The actual materialized view, you load that and you get the catalog reference, but we need the UID of the table to verify that the storage table hasn't changed underneath that. And we need the snapshot to make sure that that storage table has not changed. So I think this is right. I think that we've got everything that we need in order to evaluate this.
I think it would be fair, like this way, like we need to wait for the catalog calls to come back in order to start the next catalog calls. I think if we had the identifier immediately, you could make them concurrently and it would be faster and we wouldn't need to kind of sequentially go.
Well, yeah, sorry, Dan,
Yeah,
go ahead.
That's fair. Like, you know, you could optimize this by saying, hey, let's include all of the table references in that first list. But then somebody would have to go through and compare this versus what's in the other list, pick out the storage tables. You know, tell it.
I see one issue, you know, if we put these informations in here for make the things are faster, we will not know if it is changed on the catalog side.
No, it's still loaded, right? Because we're still, like, I think what Jan is saying is, like, optionally, you could put the storage table under the source table reference as well. And then when we go and do the load tables, we can do them all together, all at the same time. We don't have to do this serial, load the materialized view, then load the storage table. You get them all in one shot, right?
Yeah.
I understood that, but I'm trying to say that, you know, this source table we are going to use on the client side for the evaluating the freshness. And what the Jan wants to do that, basically, he doesn't want the client go to catalog and get the informations, and in the one materialized view shot, then client can evaluate all of the nested informations, or not the nested, but the first level of the nest informations. But at the same time, the catalog may change those informations, right? If you're not calling the catalog, you cannot know that those things are changed.
I think you have to call the catalog, or at least outside the max staleness window. There's no way around this.
Yeah, I think Jan's point, if we store that here, we will just do one round trip, don't have to do two round trip. To load, if originally we need to load the source material view to get storage table name, then load storage table. That's what Jan was saying. I think, yeah, especially with the bulk load API we're talking about, that's in the REST catalog. Yeah, if you can parallelize, you can potentially just do one bulk load for all the source table, all the view you need, and just resolve it.
Yeah.
Then this is the implementation program, right? We should keep this spec as simple as possible. Like the materialized view has to be like view, and the client has to resolve by calling the catalog. And for feature, if you have a bulk endpoint, client can't call the bulk endpoint and resolve these things for me and get back to.
So I don't think that changes anything from what we have here, though, Jan. Like, I mean, it's just a question of, like, in the implementation, do you load the storage table from that source table list, or do you load it secondarily after loading the MV? But I think leaving it this way, we can say, well, if you find it in the source table list, you don't need to make that extra call. You've already loaded it, right? If you don't find it in the source table and there is an expectation that there's a snapshot that you have to validate, you would have to grab it out of you'd have to load the actual table from the catalog after you load the MV. Does that make sense?
Well, if we go that approach, that we should not put the storage table. If we put that combine, that means we cannot.
No, I think we do want that for the association between the view and the storage table, right?
At least the UID.
And also, we will not put the storage table name. There is no way to loading. If the storage table has available on the list, the client can compare it on.
So you can load it, but you have to load it through the MV. So you have to load the MV first, and then you get the storage table, you load the storage table. And Jan is saying, like, hey, we can optimize this by, if the provider includes the source table in the source table list, the actual storage table in the source table list, you load it along with all the other source tables. And then we just need the UID to say, like, hey, have we already loaded this thing, or do I need to go and load it?
Then we can use UUID for the validation, right?
Yeah.
Basically.
So I think we need the UUID and the snapshot to
Yes.
complete the validation for the MV. Whether you do that based on the table that you load after you load the MV or the one that was in the source table list is just implementation and optimization.
But we should not include the source table name.
We don't need it here. It's not
Okay.
necessary to have here.
Okay.
Because either you load it from the source tables and you can compare on UUID, or
Does that mean
you load it through the MV and you get it from the MV definition.
Why do you want to complicate the data model, right? Like why do we want to put the storage tables into like the source tables? Like they're separate. They're separate entities, right? I mean, like if we're going to have a type for source materialized view, then let's just keep everything that's related to a materialized view with this type, right?
Yeah.
And also I want to say, let me finish. Like there's another, like I also think we should have storage identifier in here as well. I mean, like there's also another use case where like the consumer to validate freshness, he only cares about data. He doesn't care about like changes to view sepals, right? And so I only want to look at like the source table and the storage tables, and that's it. I don't want to validate views or the materialized view versions. Okay, like that's what a consumer wants to do.
Igor?
So I think consumers sometimes want to ignore SQL changes, sometimes we don't. Like if my data was stale for last year, nothing changed there, and my view is fresh, that's fine. Sorry, my materialized view is fresh, that's great. But if view schema changed, that non-trivially impacts stainless, right? And different clients will make different decisions there.
Yeah, I actually see that as more of a producer problem. If the producer changes a view definition that's incompatible with the storage table, it should wipe out the storage table. You shouldn't be able to evaluate freshness at that point, right? Because now that view is like, if it's done in an invalid way, if the SQL is evolved in a valid way, then it's kind of up to the consumer. Do they care about the SQL or not? But if you're doing an invalid SQL modification, then you should actually be invalidating the storage table.
But for producer, it's really hard. Think about like, I broke one materialized view in an incompatible way. Now I have to traverse all the downstream dependencies and break them as well. Most agents don't do that, right? That's what we're talking about here.
Oh, I see what you're saying. That is true. That falls into this category of nested MVs are not really
right. And that becomes consumer responsibility, and some consumers will choose to do that and some consumers will not. I don't think we should hard code for one scenario or the other. I've seen both cases.
I agree with that.
But that's just feedback on Danny's point.
I agree.
And yeah.
So I think list we're talking about single list. There's no separate source table list. We just have single list with different state. So if we talk about having the source of material view storage table information in both source MV state and the source table state, kind of would duplicate some of the information. And also we are saying that we allow the producer to decide recursive now. If they say producer, I don't want recursive, I may not even have source MV storage table information. I don't need a consumer to evaluate them.
Can you repeat that? I actually didn't follow what you said in your first point.
Look, I think, Daniel, what you said earlier may have been misinterpreted. You made a claim saying, hey, when you parse materialized view upstream dependencies, if you already happen to have that table, you golden, you don't need to load it. I think what you meant to say is, if there is a direct query on the table, it's cached, it's awesome, you're good. I don't think you meant to say that table entry should be duplicated just as a result of materialized view being used in the query. I don't think that was your intention, but I think it may have sounded that.
Okay. Yeah.
Did I get to like, correct me if I'm reading this right?
I believe that's what I was saying. I think let's just kind of go through from the high level, like what do we include in the source table list, right? The source table list includes any table that the producer determines needs to be validated for a freshness check of the storage table for that top level materialized view, right?
Does it include materialized views?
What?
Does it include materialized view storage tables or not?
I'm just talking about the source tables. It doesn't include the materialized view source table. So that was a discussion that we were just having. And I think it can include materialized view source tables. In fact, we probably suggest that, yes, you should include it if you're going to have a materialized view reference. Right? Why? Because then you have already loaded the table when you get the view definition, the materialized view definition to validate, right? That was your point, right, Jan, right?
Yes.
So
well, keeping in mind that we currently, the design is to have a single list for both source tables and source views. So we were just talking about the source table list. So we currently have like one list with different types, right? Just to reiterate that.
Daniel, just to clarify, so if I have a really simple materialized view that is as my materialized view, MV1 is select stuff from MV2. That's all. I will have two entries here. One is a base table and one base materialized view.
Yep.
That's the proposal.
Yep.
Okay.
Yes. I think that Benny wanted to kind of merge those two together.
Yeah, because I also think now we have duplicate information, right? There are some duplicate information.
What duplicate information? I would say, like, we have the storage table information, it's a table, and we have the MV information, it's an MV. So for any client, what?
And we also have some storage table information like this.
Yeah, that is
the storage table ID that would be duplicated, but I think not anything else wouldn't be duplicated, right?
I mean, you're saying duplicated, but like, I think it is the association that ties that MV to that table, right? Because we can't do it based on name because we're not capturing the name here. And for a client that doesn't want to recurse and look into nested MVs, like, they can just evaluate it based on the storage table and the MV. We have to load both anyway.
Okay,
right. We don't need we need the UID, but we don't necessarily need the snapshot ID because it could be stored in the other table entry.
That's not true. You have to carefully resolve duplicates because in my case, MV1 reads from MV2. Let's imagine MV2 reads from my base table and MV1 reads from union of MV2 and base table. Then the same table shows up directly and indirectly. And at different timestamps. So you have to do either max resolution or like some non-trivial logic to make sense out of that.
So if we store them separately, I wonder why do we need the association? Because we thought about, let's say, it could be case the producer doesn't want the consumer to evaluate the source MV store table. I want the full recursive behavior. I may not even have that source and material view storage table in the list.
Yeah. So either we take the approach that, like, you only provide the materialized view information that we have here, and then you have to load the materialized view to validate it and take that extra hop. Or we allow for putting that storage table in the table definition, right? Because we have to have this. And the problem is, if we don't have values that associate back to the storage table, I don't know there's an association. So I always have to load the materialized view. At which point, I don't need to include that storage table in the table list. So if we want to go with the, pure non-optimized, let's not worry about how many calls are made, you would not include the storage table in the storage table in the source table list, and you would purely reference it from the MV. You have to load the MV, then you have to load the table, right?
I actually kind of prefer the two separate entries and have no association. Basically, once the producer provides this list, then consumer still just evaluate the view and sort and the table. That's it.
But then I have to load the MV, and then I have to use the MV definition to see if it's in this source table list or not.
No, because producer, let's say I wanted to only evaluate the top level, so you don't need to recurse beyond. I will put the storage table, the source material view storage table in the list. Otherwise, I may not even include it in the list at all. I may include the recursive source table in the list.
But the evaluation is based on the consumer side. It's not the producer side. The producer just, update the tables, but the client will decide the refreshness.
So, Stephen, I think in your case, you wouldn't even include the MV in the list, right? Because if
Well,
you're
I
saying,
would-
hey, I don't want you to do recursive evaluation, I don't need an MV definition in there.
I will
But you're also
include the
preventing clients from doing MV evaluation at that point.
no, I will include MV so you can validate the view definition, that view version ID, but I won't include the source MV's storage table information at all. Let's say if I just want to do a full recursive, why do I need to include the source MV storage table? Because I don't need to evaluate that one.
So you're saying only encode enough information to check the version of the MV, and then a producer should only look at source tables to validate table state. And a
If the
storage table
producer-
may be included there or not.
Yeah, depends on if the producer wants the recursive behavior or not.
Is it are we saying that recursive behavior is purely a producer decision?
Well, I say it's a largely producer decision, but if a consumer really wants to do something additional, the MV is here. The consumer won't do anything actually. I guess we're not preventing it, but we don't in the refresh state, we don't have additional information for them.
I think I can get behind that argument. That actually makes sense. That okay, we're just saying that for materialized views reference, the only validation you do based on this is UID and version of the MV.
And the producer may put additional recursive or non-recursive table state in the list.
Oh yeah. That's just like, I mean, all we're saying is that like, hey, for a source table, regardless of whether it's, you know, top level directly referenced by the MV or a nested reference, you know, whatever it is, all you're doing with the source table is validating that the UID is correct, the snapshot matches. For an MV entry, you're purely validating that the UID matches and the version ID matches.
Yeah.
Just to be sure, we are keeping a separate materialized view type and not just using the view type, right? Just to set that I understand correctly.
Well, we haven't gotten there to say like, now that we've done this, is a materialized view and a view exactly the same thing? And like, what does it matter? You know, because if all we're doing is checking the UID and the version ID, that's all consistent with a view definition too. So is there really any difference between a view definition and a materialized view definition at that point?
So that's why I feel it's a little tied to my earlier question, how we load it. If that API to load the material view in one shot, I in that sense, have a material view type maybe.
I'm not convinced that it matters. But like the load, right? You still, I mean, we haven't updated the REST spec for this, but I would assume that we would return the materialized view from the view load, right? It's just a type of view that has additional information. So we would include the additional information in the payload that we return.
Mm-hmm.
So it doesn't really change the number of requests or, you know, anything like that. And the only thing that we validate is the UID of the view to make sure that the view hasn't changed, and the version to make sure that it hasn't substantively changed. Then what does it matter whether it's a view or a materialized view?
I think it matters because if we have that combined loading, then the storage table and we storage never need to expose to the client. So you never load a MV storage table directly. You always load the MV. Then there's no separate loading of MV storage table. Then there won't be any like a MV storage table in the source table state. If we can enforce never expose the storage table for MV to the client.
We had this discussion already, right? And I think at the time the consensus was that having a separate storage or kind of keeping it simple and not creating like new artifacts, or so that you still have a reference to a storage table and you have two entities.
Yeah, I'm not saying we don't have two entities, but I'm saying the loading from client perspective will be one entity. In the actual underlying storage, yes, you have two entities. In the catalog, you have two entities, but from client loading perspective, could that be just one load? I'm just loading MV. That's it. And
Daniel, I think in your model where you say, can I really think about materialized views as views only and then check reversion and stuff? I think you missed the point of, I do need to understand when the upstream materialized view was refreshed.
When the upstream view is refreshed, like, well, so the thing is though, like when I actually load it, I will know that it's a materialized view, right? Putting
So
that here doesn't change the fact that when I load the view, I get a materialized view back. And I know at that point that it is a different thing. And I have to do a different check for that. But what we're talking about, like, what do I actually need to, what's the minimum set of things that I need to include in this list? And I don't need to know from the list that it's a materialized view.
fair enough. I was under the impression that we're trying to get into the model of you just list everything and you load everything, but I think that was my mistakes. We're trying to include minimal set of things that you can process freshness without SQL parsing. That's the goal, right? Okay.
so I guess we can start with just view type and table type. And in the future, if we have the bulk loading API or the combined loading, that's maybe the time we can choose MV type. And if you want to do any additional tweak. Right. So for now, they have to load the sort table separately. Let's start with that. Just have those two types.
It gets more simpler, right? We will drop to materialized view state now.
Yeah. In the future, we can maybe I'll come edit it back. If we say we can like hide the storage table.
Save this PR, Jan, like this current, like if we end up like arguing ourselves back into this, like you don't have to rewrite it from scratch. But I think, you know, if we want to take the simplest approach, it would be just storage table and just view. Storage tables, you're validating snapshot. Views, you're validating version ID. And view, it's on both of those. Like making sure the entities.
Not storage table, right? Source table. Storage table is the.
Yeah, sorry, source table. All tables are source tables, right? You know, anything that we put under source table.
Okay.
Because at that point, the storage table is the source table.
Yeah, I think that makes sense to start with. Benny, do any?
Yeah, I mean, I'm okay with that. I mean, I'm all for simplifying things, but I'll just say the con, right? That I can. Main thing is like if you're a consumer, you hit a view inside the list of views, you don't know if the producer actually expanded that view or just used that view as a materialized view. Like,
Well, the how producer properly refresh state is kind of tell you how the producer want the consumer to behave or evaluate.
really? So you're saying that the producer, if he uses it as a materialized view, then he'll put the storage table in there. And if he actually logically, if he expanded the materialized view, so ignore the storage table, then he'll put all the, you know, underlying source tables into the list, right?
That's exactly correct. Yes.
Okay, let's go with that for now. Yeah.
Okay. Sounds good.
Should we capture this behavior somewhere else, like the producer, how the producer produced the source?
Yeah, that is already in the previous. It's in here already. The producer can. We could expand it possible or not.
Okay, but on the spec, did we write it, Jan?
Sorry, could you repeat it?
Did we capture this behavior? What is the current behavior like? You know, if producer wants to put the source table, sorry, storage table as a source table, it can put on the source
I
table.
think it should be here. Like it's like it's kind of the interpretation of the producer kind of matters, and depending on what kind of semantic it wants to have, it can include them or not. And it's kind of
Okay, makes sense.
Okay. Let's go back to we have 50 minutes. Benny, your second open question?
I would like to skip this question because I feel like we have a more important question, which is this diamond shape pattern and whether how we encode like the lineage of the source tables. So I'm curious to see what others think about that, because like, you know, in Igor's example where like the source table appeared in multiple versions and multiple times in the query tree, right? Like how
there is also thread here with Igor, Yang, and me. Let's see, let me.
I think you should go to consumer section. I think
not sure.
Jan captured our current opinion reasonably well.
And I think Igor, you picked up on my comment, because I say unique dependencies, right? And I specifically said unique, right? Because I wanted to point out that like in this, because a query tree is a graph, right? And then, you know, but the nodes can be duplicated in terms of like the scan like paths, right? And so I was saying unique. And so that means it's up to the producer to decide, like when I have duplicates, which one do I pick, right?
But are people on the same page? When I talk about diamond shape, are people aware what we're discussing here, or is that confusing to people?
It's clear.
I'm not sure I'm convinced that I understand the diamond shape.
Oh, okay.
Is it that the reader read the same table through two different materialized views at different times?
Yeah,
Right.
I think I'll have a link here.
Potentially. The different snapshots of the same table.
Like
This is common issue for almost all of the
MV1
nested.
and MV2 both can have the same source table, table A. It's kind of diamond shape we talk about.
Yep. So, I mean, this only becomes a problem if you're trying to do recursive evaluation, right? Because from MV3's perspective, if MV1 or MV2 are both fresh, even though they had different read times from table A, you're fine.
No, not quite. Imagine the same picture, but MV3 reads from table A directly as well.
That's still technically fine, as long as like MV3 looks at table A and what is defined in the source table, and it says, hey, that's a good state, and MV1 reports fresh state and MV2 reports fresh state.
How do you determine MV1 fresh state? You need to look at
It's part of the statements, right?
It's up to the producer. So if I put my storage table and an ID and a staleness window, that can determine whether it's fresh or not. If I put table A at a different snapshot, now you have a conflict, and then it's a question of, can that even be resolved, right? So if I have two different states, a dumb client is going to say, whoa, I can't even evaluate this, right? It is inherently a conflict. A slightly smarter client may be able to look at the snapshots and say, hey, look, table A in one case is current, and in the other case, it only has rewrite operations, right? So I know that the data is unaffected. I can still consume it. An even smarter client would be able to parse the SQL, check the filter statements, see what was updated between different states, determine that there's no overlapping, and still execute the query. But a dumb client is going to just say, hey, this is inherently a conflict. I can't resolve this.
In your second case, where you have moderately smart client short of SQL parsing, would have to handle multiple table A entries or different snapshots and argue about each one independently, more or less.
Yep, because they have to be effectively the same. From a data standpoint, they have to be the same for a client. So that just means about the only thing that's allowed is a rewrite or some non-data affecting operation that added a snapshot. Because then
you can have mutations within staleness window.
That's a good question. I guess yes, within the staleness window, I think you could say, yeah, we will allow that. So as long as the changes are within that, we'll.
And also staleness window is defined by the user, right? The consumer itself. Basically, they should be okay for that.
Staleness window is defined by the view definition.
Yeah, that's why I'm saying that whoever defined the view, they say that I am okay.
So I think we all were like, what?
Okay, sorry.
But I think
Yeah.
we're saying the same thing.
I actually really like the idea to only include kind of the older snapshots, because I was thinking about this, and for me, I think you can kind of prove that the newer snapshot, if the older snapshot is within the staleness window, the newer snapshot will also be in the staleness window. And if the older snapshot is invalid, the entire material or is stale, so it only takes one out of date source table to make the entire materialized view stale. So I think you could prove that as long as the older one is stale, the entire materialized view is stale.
Yeah,
So
It depends on if you want to do recursive or not, right? Because if MV1 has a larger staleness window than MV3, right? And if MV3 is actually referencing table A, then the older staleness window would actually result in MV3 expanding its staleness window. So it's not, I don't think it's just a hard and fast, like, hey, you just, like, for all the references, you just include the oldest one if you care about, you know, enumerating all of the nested references.
I think I agree with Dan. If it's non-recursive, it's not a problem. We only talk about when we talk about recursive behavior. I think for recursive, if we only store the oldest snapshot ID, I just don't know how you can move forward. Because when you, let's say, when you want to update, you don't know where this belongs to, because then nobody can move this snapshot ID forward, because it's always the oldest. I have a newer one, but I don't know if that was set by me or set by the other path.
You don't get to know, like, if MV1 was refreshed, it doesn't impact MV3 staleness state.
No, but when MV3 look at MV1 refresh,
Right.
should I update the table A source table state?
Right. You look at all of your children, you do the max calculation again, and you put that on record.
Or you look at all the children?
But that gets you to the point where you can extend the MV3 staleness window, right?
This is also depends on
no.
the definition, right? I believe we are discussing about the when I create my MV, I decide my staleness window, and if my MV2 is say 15 minutes, MV1 is say the 30 minutes.
Okay. So I guess what we're saying is the MV3 staleness window overrides all the other MV staleness windows if you're doing a full recursive search.
Yeah.
So even though MV2 may report that everything within it is within the staleness window, Jan, do you see what I'm saying here?
yeah, sure. I mean, it's about how you define it. Which semantics do you want? Interpreting it's this way, would it make it easier for the calculation? But it depends on how we want to define the semantics.
This feels like it's very confusing. I would say that I am somewhat comforted in the fact that I don't think this changes what we're talking about in terms of the representation. It's more about how do we recommend people build the list of source tables and MVs, right? Because the producer can decide what it wants to include for those checks at any level. And then we just need to establish that, like, hey, if you're going to introduce things into the source table list, it's the staleness window of the enclosing MV, the top level MV, is really what's being applied to it, not anything within the other MVs. Because we've already said that, like, hey, if we're going to include all of the source tables that we care about in that source table list and not do the recursive evaluation, then we have to apply the same staleness window for everything in that source tree list.
Yeah. Should have the oldest snapshot can work, I guess. Yeah. And I think the semantic that Dan described also makes sense.
I think, but that kind of contradicts the recursive evaluation though, right? Because if you were going to go purely with the, hey, in my MV, I'm only going to use the top level source definitions, you have to load any reference materialized views and then evaluate those. If you're evaluating those recursively, you can then evaluate all of the staleness windows recursively as well.
Well, I think the recursive means I need to load the table A from catalog to compare the catalog state with my refresh state. Because I cannot just look at MV and MV1 and MV2 storage table. That's what recursive means. Now recursive means I don't need to evaluate table A state from the catalog.
I'm not clear about the one thing. Maybe I couldn't follow that. My MV3 has, let's give the numbers, the 5 minutes freshness window. Then my MV2 has 15 minutes and MV1 has 30 minutes. Because I am evaluating the freshness on the first level, I will going to look at the MV2 and MV1, and I will not go to table A, if they are fresh enough. Is it?
For example, recursive behavior, the sort table state, we have MV1 sort table, MV2 sort table. Then you compare them, from the refresh state compared to the catalog state, if they are within the 5 minutes status window or not. For the recursive behavior, the sort table state, we have table A, whether it will be 1 entry or 2 entry, let's leave like there, but we will have table A state in the refresh state, and compare and load compared to the table A state loaded from catalog. That's recursive behavior. And both sides will be 5 minutes status window. Both will have 5 minutes status window.
I think we're redefining max staleness in terms of recursive and non-recursive behavior. And it sounds like if we choose the recursive behavior definition, our simplified check is actually becomes unreliable, right? Even if my immediate upstream MV was refreshed a minute ago, it may have some really stale data that I cannot trust. So if I like, what it means in my mind, if you really adopt that model, max staleness should have two definitions. Here's recursive max staleness and non-recursive max staleness. And I hope we will not go there. I think we should converge in one model that we can explain in 2 sentences, right?
That's why I have that second question where I'm saying, like, should we not even have max staleness, because now you have to start defining variations of it.
No, I don't think that we want to go away from max staleness. I think it just comes down to how do we interpret max staleness in context of the materialized view itself, right? Like the top level enclosing materialized view. What does that really mean? That means that if anything has changed underneath me, you have up until the end of that window to consume from the storage table.
Yeah, I was like that simple behavior. Whatever in the source table, just check how far they how long they drifted compared to catalog state. Right? Are they outside the status window or not? That's simple. Just that's no recursive. Yeah.
And that is what we defined as the coarsest grain check somebody can do and still be within what the producer intended for consuming the data, right? That because it doesn't matter what changes during that staleness window, you're fine consuming from the table. The question after that is for the more refined engines or the more complicated engines to then say, well, now that I'm outside of that window, can I determine whether that data is still fresh or not? And what does that mean? So when we're doing these calculations and nested comparisons and stuff, like we're outside of the staleness window already. And what we're trying to determine if nothing has changed that would impact the results of what was in the materialized view. Igor?
I think you're missing a case here, Daniel. So again, imagine materialized view embedded in another materialized view. Imagine we adopt the recursive definition of freshness, where we say data seemed to be fresh if I could have gotten the same result if I did logical view sometime within staleness window. And I do a recursive thing and say logical view, interpret all the upstream materialized views as logical views. That's our recursive definition to kind of converging on. If I did a refresh a minute ago, I might have captured data from my upstream that was just on the margin of being stale. and that data becomes useful for next minute, but not for the full window.
I'm not sure that you can make that argument, right? Because if you basically, at any point within the max staleness window, any data could change, right? The view could be refreshed within the max window, like any of the downstream table or, any of the source tables could have changed,
Yes.
any of the source MVs could have changed. And what the definition of that max staleness windows means, none of that matters.
Okay.
If I'm within that window, I can consume from the storage table. That's what you have told me I can do, right?
But that's a shallow definition. That's non-recursive definition of staleness. We can have conversion that, but that's different definition. That's
I don't
fine
think
too.
that violates the recursive definition, because what you're doing is you're saying, hey, all the things that contributed to this table are part of my table staleness.
Imagine my staleness is 1 hour. Imagine I refreshed my data based on Materialized View that is 50 minutes stale and has 50 minutes stale data inside it. So how long can I use that Materialized View that I just refreshed going forward with simple check? Can I use it just 5 minutes or can I use a full hour?
You can, if I reference you with your definition and I'm creating a Materialized View, I set my staleness, right? And when you consume from me, you're accepting anything that happens underneath me, right? So like whatever my staleness is, I'm defining as the result of whatever I produced. And that's up to me to decide, like, hey, do I need to include guarantees from my upstream tables, right? But I don't think that means that my staleness gets invalidated by a nested staleness. Otherwise, we can't do the simple coarse grain check. Like that would be invalid.
So, and I think we're over time. I think Kevin probably wants to say the same thing. I don't know if people want to stay for a few more minutes to wrap it up, or we.
Let me check and see if I can stay.
Yeah, I don't think we're gonna get kicked out, but
Yeah.
I think depending on preference.
I mean, I do think this is an important point to settle, Igor. It's kind of this question of like, do we need to take into consideration the expiration of staleness within our staleness window? And I would say no. Like the definition of the staleness window is like whatever I produced, I said you can consume until the end of that window, regardless of whatever happens, behind the scenes.
So that's fine. I don't mind that definition, but that's a shallow definition. That's one level staleness. We should spell it out because I think our spec is not precise in that regard.
So I think that I'm saying that is the top level staleness. Anything that happens under, like even with recursive evaluation and things like that, you are always guaranteed to be able to read from the storage table within the staleness window.
Yeah, how useful is that though, right? To have such a coarse level like staleness, because then if you look at what other engines have for staleness, right, like that is
actually, with the exception of like what we had discussed before, like dynamic view or dynamic tables or things like that are kind of being used to build pipelines and other things based off this. Most of the industry does not consider materialized views as part of their staleness calculations, and the majority of cases people are using materialized views is that they're like preparing a data set either for like consumption via BI or reporting or something like that they're trying to guarantee will be good for some period of time, which is why they all include this kind of staleness guarantee. So I think getting rid of staleness would be a real problem for consumers. You wouldn't be able to consume with dumb clients because everybody has to do a complicated analysis of staleness, right? Based on the actual SQL text. And when you get into the recursive case, like this is kind of, I think the reason like a lot of people shy away from the materialized view recursive evaluation is because then you have these conflicting things of like, well, what does it mean for my consumer if I say it's stale for, or staleness is good for an hour, but all my MVs said only 5 minutes. Like, is that stale? Is that not stale?
Daniel, but if I adopt your definition, actually, I think we solved all the problems that we talked about last hour, because you're basically saying my staleness is shallow. I don't care what happened below me. Here is the list of immediate references. Forget about diamond pattern. Like the whole model becomes like, I don't know if it's very useful in deep scenarios, maybe not, but the whole model becomes really, really simple, right?
Yeah.
And maybe if we don't close the door for the more complicated definitions in the future, maybe that's a good starting point.
So let's talk about the more complicated cases and like how you address that under this model. So one option is you actually just set your max staleness to 0, right? Then every client has to evaluate the state of every table that my producer puts into that view definition. And I can set any of those tables to expire when any of my nested materialized views would have expired, right? So
that's not equivalent to deep staleness model though, right?
It's not in that you don't evaluate staleness at every level of that dependency tree, right? You're basically saying, I'm going to, I mean, unless we do the recursive evaluation, right, at that point for staleness, like, because then I could just reference the materialized view, and an engine that wants to do recursive evaluation could go evaluate each one of those views to determine whether everything is still, you know, within staleness as defined by the views, right?
I have a simple mental model. Let's say we just talk about top level, MV3 reverse state. It just has a list of sort table state, and we load those all tables, look at their snapshot timestamp, compare the catalog, the state we load from catalog. That if it's a recursive, that sort table state will have table A, based on the oldest snapshot that the Yang and the Eagle were talking about, and just compare to the catalog state. That's it. Why we have to? I don't care about what's the staleness for MV1, MV2, because when I produce the reverse state for MV3, I have a list of source tables. I have a max staleness. Just do that simple evaluation.
But if you have something else on the, the source table for MV1, then you want to use it. That's why.
No, but if I do non-recursive, yeah, I will put MV1 store table in source table set. Table A will not be there.
Yes,
but
your
I don't
producer.
care about the max staleness config for MV1 and MV2. I don't care. I'm going to evaluate MV3.
I mean, it doesn't really, okay, so it doesn't really solve the problem that Igor mentioned, right? Because effectively, like, if we go with the staleness definition of like a max staleness, within the max staleness, you can consume from the storage table. Like, that is the simplest, definition of what the staleness window means. I don't have to do any evaluation. I don't have to load any tables. If I'm within that window, I'm good, right? I think then the next question is, well, hey, if we could either water down that definition, but that makes it very complicated for consumers, or we could say, after that staleness window, we need to define how do you evaluate staleness? And now we run into this problem of what does it mean for nested materialized views? How do we define, or how does the producer indicate that the state needs to be evaluated for each one of those views within a freshness window? Because you can't do that with just the list that we have. So I don't think we can even represent currently a producer saying you must evaluate each one of these nested materialized views with their staleness. I don't think we can represent that.
And I think also the simple logic where you say, hey, within staleness, you should be able to consume, period. That has projections into how do you interpret the tree, right? Because if you really believe in that logic, it means whatever stale data was captured in your parents, that doesn't matter. And probably that policy shouldn't magically change when you cross that line. You should express it in a consistent way for recursive closure. Did that make sense, or did I mumble?
So to the example that Tyler mentioned, like MV1, MV2, MV3, they have different staleness window. If we do the recursive behavior, if we store table A, do we care about MV1, MV2's stainless? That's my question. Oh, we
No,
don't.
no, I'm not even talking about that. Forget about the MV2 stainless. We care about
can I
state
answer
of
the-
the captured. Yeah.
Steve's question, I believe this is depends on the client itself, right? If client is dumb client, it can evaluate directly the MV1, MV2 stainless for MV3. But if it's a smart client, it can go all the way down and decide that as a nested way.
I think I'm getting confused here.
I see your point. And I think I really like the delayed view semantics that Igor proposed. And I think going back to this very simple max staleness, I think we're losing a lot of functionality. And if we interpret delayed view semantics as like, I'm blanking on the definition right now, that if anything within the max staleness, if I would have run a query within the max staleness window, I get the same results as I get from the storage table.
Correct.
That's still valid. And I think this is also okay if we apply the example that Stephen just said, that if I define kind of my max staleness window, I want any change that happens, that I want to get the same data. So we just have to evaluate table if a table A changed in the meantime, and we can deduce whether we're kind of within this definition or not, or am I wrong?
But we're redefining max staleness at that point. If the idea is because your max staleness is actually indicating things can and possibly will change. So we can't ever say within max staleness that like you're redefining it to be a guarantee that the data won't change within that window, and that's not the case.
No, I think false positives would be, Jan, I think going back to the delayed view semantics, it goes like, I deem my table fresh. If I could have run logical view of my query during the stainless window, would have gotten the same result. The only place where that definition is ambiguous is how to interpret my upstream materialized views. Do you expand them as views, or do you treat them as tables? And depending on which way you go on that thing, you will get two different max stainless flavors. And I think that's what we're deciding right now. And they have very different properties.
Are we okay for very basic, the max stainless evaluating the top MV as Daniel mentioned that? If we are okay with that behavior, I believe we can start implementing this materialized view.
I would
But I
start
think
with
this
simple definition, non-recursive definition. I would say, hey, if I've gotten this query, expanding just myself, not children. And during this time, we'll get the same result. I think that's reasonable, shallow definition. I think that's what Daniel is, that would be consistent with Daniel's point. It doesn't, maybe not very useful in a lot of scenarios. Somebody can argue that there is a lot of value of delivering max stainless, but I think stainless simple definition is probably a bad idea.
So I would argue for just an also simple approach, which is whatever the producer put in the source table state, whether it's table A or it's an MV and MV2 store table, and just evaluate that one with the catalog state for the max stainless. That's it. Why is that? I think.
So you're advocating for when you have nested materialized views, you're evaluating the staleness for all reference materialized views to determine staleness.
No, whatever table the producer put in the source table state, whether it be table A or the MV and MV2 sort table, just evaluate those source table state against max staleness. That's it.
Well, but that's not what max staleness is, right? Like those tables can change. Max staleness is saying within that time period, anything can change, but you can still consume from the storage table.
Yeah.
Like,
so
if you're within the staleness window, you shouldn't have to compare anything.
No, I'm talking about the compare MV sort table with, well, we're talking about MV1 and MV2, the nested sort table. We are evaluating MV3 freshness we're talking about. We're all talking about with the top level.
But if okay, so let's starting out, like if I'm within my staleness window, at least with the simple definition, I don't have to evaluate anything. I don't need to look at any of the referenced things because I am within the staleness window. I can consume from the storage table.
Are we agree, all of us, for this?
Yeah, that is a cost grain evaluation, right?
I mean, this is a prerequisite for the next step. That's why I'm asking that. You know, if MV3 is in the freshness state, we will not going to evaluate others because we are going to consume from the storage table, not the source table.
No, I think last time we said they are required to evaluate to the cost grain evaluation, but they can do additional evaluation.
This depends on the client.
But the additional evaluations cannot supersede the coarse grain evaluation, right? I can't say the coarse grain says I'm good, but then the more fine grain says I'm not good.
Correct.
That's not allowed because then you have two different definitions of staleness.
Correct. Yeah, but if the cost grain says that you are stale, you may go additional say it's actually fresh. Yes, that's where I'm
right.
So if we pass the first check, you can just proceed. There's no evaluation that needs to be done.
Correct.
Then after that, we're doing staleness evaluation
based on
and
the
trying
list.
to determine if everything within the reference is still current, right?
Yeah. So in that, I'm saying just look at whatever stored in the source table state, and just do the evaluation with the max staleness.
The problem, Steven, in that case, if you do step 1 and it seems to be fresh, and you're extra paranoid, and you do step 2, you suddenly will find that table A is stale.
Oh no, yeah, we don't need to.
But you see, they are not consistent. Like you're allowed to discover more freshness after step 1. You're not allowed to discover more staleness after step 1 has passed.
I see.
That's the challenge.
Okay.
Are we agree for that? Now, if everybody is agreed, then we can write on the spec.
So the only alternative to that, I think, that would possibly address Igor's question is, like, you could amend it to say, like, hey, with nested MVs, we're actually going to evaluate all the staleness of the MVs. That makes things more complicated, but that would kind of address this question of, well, what happens if we had like a 5-minute MV1 staleness window and a 1-hour MV3 staleness window. I just don't, I don't feel like that necessarily aligns with most of my understanding of like how the staleness windows work, right? Because then, like, I can define mine as an hour, but it's effectively 5 minutes.
I agree. I don't think recursive parsing of staleness is a very useful model. It's hard to explain. It's hard to present to customers. I don't think that's useful. The only useful model is my staleness applies to the full tree, and if you're central consistent, awesome. If you're not, maybe some kind of you can play a little bit with data, or you just guarantee you immediate staleness. And I think we should stick with a simpler model to keep our sanity intact.
Yeah, I can agree with the previous assumption. Hey, if the cost grain pass, I don't need to go further. I think we can start with that simple approach. If cost grain says stale, then you can do the additional competitor list.
And the thing is, like, you can get, I think, what you're looking to achieve in the case where you actually reduce your staleness to something very low, as long as you can do the more complicated check and evaluate everything, you can go well beyond that staleness, that, you know, whatever the 5 minute, 1 minute, whatever low staleness you set, as long as your engine can evaluate the more complicated things. So if you want to build, dynamic tables or pipelines, it may even be 0, and you're just letting the system do the full evaluation every time and refreshing everything. The staleness window is largely for clients or slow moving, data that a producer wants to provide externally. Igor?
But if we adopt that shallow definition, does it mean spec should mandate not putting entries below the first level dependencies on our list?
Why do we need to skip that?
I think that the spec should probably just state what needs to be validated and what can be put in that list. Because again, I think we want to be able to reference other things within that, and include and exclude based on what the producer wants to be evaluated for the freshness of the table.
Yeah, although
But you see inconsistency there, right?
I
don't.
I don't because it's mostly just the producer defining here's what needs to be checked. We define the rules of how you check. And then you can leverage that to solve lots of problems, right? So if I've got a table that is, external and I want a check against it, I can produce a temp table that just has the correct information just to validate, some external table or something like that. It provides a lot of flexibility, and I don't think that we need to be over prescriptive in the spec. We just need to provide a minimum to make sure that we get the behaviors that we're looking for.
We need to give the tools for the implementer, then the rest of the things has to be on the hands of the implementer.
So let's walk through that. Let's say we stick with the delayed view semantics without expanding view recursively. Really simple model. I can do simple check, that works, that's consistent. The question is, when I do more complex check and the producer happened to put more tables on my immediate upstream dependencies in the list, and I discover an entry that is outside of stainless window, how do I resolve the inconsistent result from the naive check and from the full traversal?
So you only do the full check after the naive check is already expired, right?
Yeah, I think
I see. So within naive check conflicts that.
Yeah, because you when do you do that nested evaluation? Well, I only do it if I'm outside of my max staleness.
That's really we'll have to roll it back to what's the definition of max staleness? I think it creates really strange definition.
But the max staleness is also applied when you do the list comparison, right? When you actually look at the request state, it's also used in that also.
So at the top level, max staleness is just very simple. It's if I'm within max staleness, I can read from the storage table. So then if I'm evaluating all of these other things, like if I'm evaluating a referenced materialized view after the top level staleness window, I evaluate that as if it were its own materialized view. I say, hey, is it within its staleness window? If it is, I'm good for that MV check, right?
So here is a scenario that's going to be really strange. Imagine my materialized view is outside of stainless window. I did a simple check, it's outside, I'm sophisticated enough, I can work up the upstream dependency, and I found some really old dependency from like last century, and I said, okay, it's stale, no go, really bad. Now, nobody updated anything anywhere in my upstream dependencies, but I updated my materialized view using the same old data. The state of the result of the table didn't change. I might actually be able to detect a no-op update and just make it empty operation. I put a new timestamp in there, exactly the same data, exactly the same source stainless model, but now I do naive check. I'm within my stainless window, I'm good to go. Is that the behavior we would like to document? I think that's what we're converging to. That seems very non-intuitive to me.
And this is just for refreshing the materialized view? Is that the
concept? I refreshed my materialized view, my immediate materialized view. I didn't refresh any of the upstream dependency. They're all stale from like last century, whatever. But because my timestamp moved forward without actually doing any calculations, it's like trivial metadata change. I suddenly become fresh. Yep. That seemed really, really non-intuitive.
I think that is fine though.
So may I suggest, I think we're talking about some complicated scenario. May I suggest we write it down, then maybe discuss next time. I feel the scenario discussion is getting really complicated. It's kind of difficult to follow along clearly.
I mean, I understand what Igor is saying here. Like it's more like, hey, the data hasn't moved, but I want to move forward my freshness window. But that's perfectly fine.
Because you did the check, right? Basically, because of your stainless.
Yeah, if I
shorter.
You do naive check, you got positive results, you're done, you go consuming your data.
I feel like
I think the idea is that the producer of this new snapshot also has to adhere to the same freshness definition, and it's its duty to kind of refresh the data, and then it can also give the guarantee to the consumer. But the consumer assumes that the producer gives this guarantee, and then it's kind of fine, right?
I'm not sure I'm on the same page with Dan regarding when Dan mentioned about, hey, once we pass the call screen, let's say if we need to do the event list of the refresh state, we're going to look at MV1 and MV2 are refresh. I'm not sure I'm on the same page on that argument, but
Well, if those MVs have a definition that is they are currently still fresh within their definition. If I ran my MV right now, I would get whatever those results are from that storage table. It would consume from it, so I should just consume from it.
well, let's say we do the non-recursive behavior, the source table state, we have MV1 and MV2 storage table, and MV3 is freshness, let's say, is the 5 minutes. So I should just look at the storage table. Have they updated within 5 minutes or not?
Are they fresh? We just asked the question, are they fresh, right? Because if I ran a query for MV3 to refresh that and MV1 was fresh, it would just consume from the storage table of MV1.
So when you talk about are they fresh, are you talking about from MV3's perspective, or are you talking about the MV1's definition?
From MV1's perspective. The definition of MV1, when you rerun MV3, it's going to look at the freshness of MV1. And if MV1 still says it's fresh, so this is the inverse of what we were just talking about, where let's say MV1 has a 1 hour staleness and MV3 has a 5 minute staleness, and we're running MV3 like every 5 minutes to refresh it. It's going to continue to consume from MV1 whatever the storage table has, because we're still within the freshness window until MV1 refreshes at, say, an hourly cadence. So all you're doing is applying the same rationale at every layer, which is, if it's not stale, I'm going to consume from it.
To me, I think let's say if MV1 refreshed 10 minutes ago and MV3 is next time is 5 minutes, I think from MV3 perspective, it's stale, because my storage table have been refreshed compared to the MV1 state.
I mean, my staleness can only be like any MV can only have the staleness that it defines. Like what it either needs to account for the staleness of the other tables beneath it, but it can only define its own staleness.
But then why do we need to store the MV1 storage table in the MV3 source refresh state? What's that useful at all?
That's for a more complicated client. So after you get out of the staleness window, MV1 can say, I have a 5 minute staleness window, but maybe it only gets updated once a day, right? Maybe no changes have happened to it. And that's where the more complicated clients can say, hey, this hasn't changed. I don't need to go and refresh that table. Nothing needs to happen. I can still just consume from the storage table because I can tell that nothing has changed. The staleness is purely just a guarantee that within some time frame, you can always read from the storage table.
So I think, Daniel, the definition that you're going for is a little bit more nuanced. I think the definition you're going for is delay view semantics. I would have gotten the same results if I run a view. Now, if I expand materialized view inside my query, the claim that you're making is during that refresh, my upstreams were fresh according to their definition, whatever it happened to be. That's the definition you're trying to converge on, right?
Yep.
I think that's actually flavor number 3. Yeah, we should probably write all of them somewhere and make a call.
Because that's how you're going to evaluate the recur. Like if I called refresh on MV3, how would it execute? It would go to MV1 and say, are you fresh? If you are, I'll read from the storage table. MV2, are you fresh? You're not. I'm going to evaluate and see if the dependencies have changed. Oh, they haven't. I'm going to consume from U2. I go to view and I execute the view and I get whatever it comes out from the view.
Can we write down this use case? If you don't mind.
It's just query execution, right? What is going to happen when you refresh the view? It's going to execute the query. And what is the state that it's going to evaluate during that execution, right? It's going to adhere to the staleness of all the things that are defined within that view definition, because it's executing that query at that point. And we're just saying that the same thing happens recursively throughout the entire referential, materialized views in the entire definition. We don't want something where we evaluate differently than it would be evaluated if it was executed.
So how about I think let's write it down and maybe we discuss next time. I don't think I'm not on the same. I'm not sure I fully follow.
That's why let's write down together now. Then it will be more easier for us.
Yeah. So let's. Who owns the doc?
Daniel, you are telling the use case. Can you write down if you don't mind?
Yeah. I just can somebody drop the link to this doc because for some reason I don't have that proposal link.
Let's see, I own this doc. Lost my cursor. Cursor not showing up on the screen.
This is special collections from Steve's doc.
Okay.
Yeah, anyone with a link can edit. So loading to the.
Can you drop the link in the chat?
Yeah.
And I'll just add a tab.
I think Jan already added it.
Oh,
Yeah.
Already added.
The link
Oh, okay.
In the chat.
in the chat.
I don't see it, so maybe he. I did the latest one. Yeah, he just dropped it in here. Okay, I'll update this and provide some examples.
So we basically want to say, hey, what's the source table say for MV3, and when MV1 refresh, MV2 refresh, and how should you evaluate MV3? Because we'll talk about MV3 branch evaluation.
Yep.
By the way, I asked also Gemini for that.
I've been thinking about something too. I always want to throw it out, which is we define the refresh state very like the producer gets to decide the structure of the refresh state, in terms of whether it's recursive or not, right? So what if like in the refresh state entries, right? Each entry had had a max staleness attribute, right? And so the producer is going to actually decide, right, for each entry, what is the max staleness, and then and then it encodes what it thinks is, is it going to try to do something top down or bottom up, or is it going to try to pull the nested materialized views max staleness and use that? But I mean, like I kind of see that as a way to like make it very open.
I'm not convinced that actually buys us a whole lot because every table that's directly referenced will have whatever the enclosing materialized view staleness is. Then anything that's nested, you're saying, well, we can depart in some way without clearly defining what that means. For anything else, what the staleness is.
Yeah, I don't know. Just we can noodle on it.
Yeah.
I think more sophisticated engines, and also I think these newer products from Dremio, Snowflake, and Databricks, like dynamic tables and everything. I think they have the capabilities to maybe, while I'm running my refresh on MV3 from the last example, to maybe re-trigger other refreshes that. So you were saying in the normal refresh, you would only look at your direct children and see, okay, it's fresh or not, but maybe you could also then trigger, like if they're not fresh, you can trigger them, and this way it kind of cascades down all the way. Yeah. And if you only make the simple call where you cannot trigger the other refresh, this is not an issue. But if you have these more sophisticated products, I think then it becomes interesting, and I think it would be really great to incorporate this into the spec to also make these products be compatible. And I think that's why this recursive evaluation kind of makes sense.
I don't think that we're actually doing anything that would prevent those engines from doing it, because there's nothing that says that I can't detect the state of the underlying tables and force a refresh, even if it's within its staleness guarantee, right? So for more complicated engines that say, hey, we want to run this real time, we want to keep like effectively a streaming pipeline of changes that are happening across all these tables, they would just ignore the staleness window, right? They're going to do their evaluations. They're going to poke things downstream based on their own rules. The guarantee is largely for less sophisticated clients.
And also last time we discussed the similar things from the last meeting. You know, we categorize the client like dummy client, semi-smart, and the intelligent client for this evaluation. And we have the coarse grain check for dummy clients like Python. But if Dremio or BigQuery or Snowflake wants to give better resolution, they can go with the nested evaluation all the time.
So I think the small thing we may want to add, Jan, is just that like a client is not required to read from the source table if it's fresh. I mean, for the storage table if it's fresh. All we're saying is that like if it's within the staleness window, you can consume from that storage table. Any client can just execute the view definition. Any client can call refresh on the materialized view. Any client can do its own evaluation within that staleness window, but the guarantee is that any client can consume from the storage table within the staleness window.
And this is basically view, right? Even though we call that materialized view. If the engine wants to evaluate as a view, it's also possible. We are just giving a basic least possible check for the dummy client, but the engine has the power.
I think what we are currently calling kind of this complicated evaluation is actually not that complicated, because the only thing that the client needs to do is be able to call the catalog, which it has to do anyway to get the original, like to get the MV. So it doesn't have to be a query engine. It just has to call the catalog. And with kind of a more sophisticated definition, this query engine could encode their interpretation of staleness also for kind of dumb clients that don't have any capabilities to make any queries. So more sophisticated engines would be able to still convey their staleness interpretation to dumb clients, which in the end just need to be able to call a catalog.
So,
Actually, I think the next obvious step in Jan's proposal, maybe we can delegate it to the clients and hey, when you return entry that has materialized view with stainless and we somehow define it, engine need to provide its judgment about the freshness of the data.
We say that on. I remember that I read Jan is at the something else. Or freshness under the freshness type.
No, but I kind of put all the responsibility on the producer side. I said the only kind of what we agreed on before, that the only the consumer is only required to kind of trust the producer and check, first do the coarse grain check and then just check through the list that were provided to him with the delayed view semantics, which says that if one of those things in the list also changed within kind of the max staleness, I'm still considering it fresh, right?
Yep.
all right, should we kind of recap and wrap it up? I know it's again a little late for Jan now.
We're like 45 minutes over here.
So let me recap. I think we said there'll be a single list. We have two type, view type and a table type. For the diamond shape linear, I think we're going to use an old snapshot, like Igor and Jan talk about, right? That should work.
No, that depends on our max staleness definition. We have to define max staleness,
Okay.
and then we'll know.
All right, so then with the nested material view, I think we'll work update, and Dempa will help update the kind of describe the scenario, and we'll discuss that one.
Didn't we decide that about shallow evaluation for that part? Because
that part is related to the nested material view. Maybe we should wait for that discussion.
Daniel come up with a little
Write
bit
down
more
the
there.
like I think we can write down the specific sequence, and I'll take this on of like how we want to do it, and then we can argue those specific points more clearly, because I think it's gotten a little confusing, and I think we need something very articulated to point to discuss. So let's wait for that.
Any other things that is?
Well, just to mention it, I thought your point on the GitHub thread that if we reference snapshot IDs kind of in the refresh states, but these snapshots get removed from a compaction job, we kind of don't have anything to ref.
Yeah.
So in that case, I would say the consumer can just fail, just kind of like the stale state. It can fail, it can treat the logical view, but we probably should spread it out. But I don't think it's complicated to handle.
Yeah, if you can't resolve something during the check, you should fail, right?
Or treat it as a logical view.
But I think maybe like a sequence number, since the sequence number is like monotonically increasing, I thought that maybe you could then just take the kind of the, I don't know, the next older one.
Yeah, I don't.
Yeah, actually, no. Yeah, no, it doesn't work, right? Because it has to be the same data. Like any other snapshot wouldn't be the exact same result.
Yeah.
Okay. All right. I think
Okay, then we agree. Most of everything's. Then Daniel will write just use case for the stainless, right? Is this the correct understanding? Is there any remaining open questions? Okay, nice.
So one thing I would mention is like, hey, we're getting to a point where I think we're going to need a reference implementation for this, which I think largely makes sense to do in Spark, and starting to think about, well, what does it mean to do refresh? How do we generate these? So I don't know if anybody is interested in looking into the Spark code base, either in this group, or if we want to start, calling for anybody who is interested. I don't know if somebody from like LinkedIn, Walla, somebody is interested in working on implementation, but we can spec everything out, but we can't adopt it until we have a reference implementation.
I can implement the core Java side, for those things. At least I'm not a Spark guy. That's why I'm saying that. I can do forceful link.
We can do it in core, right? Because we need something that can do, SQL. We can do pieces of it. Like we can do some of the evaluation. We might be able to provide APIs and other things to kind of automate that, so an engine can just say, hey, go evaluate this, and it does all of the staleness checks itself. But the parsing, definition, and representation pieces of it are something that we actually need an engine for.
I can't, after the core, I can start looking at, but I'm saying that I'm not a Spark guy. That's why if there is more experience.
We're gonna figure it out. So I'll set up follow-up meeting after New Year, and all right. Thank you, everyone. Happy holiday.
All right. Yeah. Merry
Thank
Christmas.
you. Happy holidays.
Yeah.
Always.
Bye.